Hi guys, Erin here. In this video, you'll learn about the scientific method, which is what we use in quantitative research. We'll start with a discussion of different ways that we can know things about the world around us, some of the pros and cons of those different ways. We'll talk about how science combines some of those different methods to maximize their pros and minimize their cons. We'll talk about the scientific process, and then we'll end with a discussion of what the difference is between science and pseudoscience. So your textbook juxtaposes the scientific method against 5 other ways that we can know about the world. Let's talk about those now. The first is authority, which is what you're doing right now as you're listening to me talk. Believing something is so because an expert said so. What are some pros and cons? Well, it's quick, it's easy, but the problem is that not all experts are experts, and often we take an expert's statement as fact without asking for a second opinion. For example, maybe we'll go to the doctor and trust what they say without going to another doctor to ask their opinion. Experts may also provide their own opinions rather than facts. Let me just point over here. Need I say more? And finally, expertise or advice might be accurate, but it might be misinterpreted or generalized in a way that wasn't intended. So in other words, don't just take my word for all of this. Make sure you do your research and make sure that what I'm saying is accurate. Let's talk about 2 other ways of knowing about the world. Tenacity is about believing something just because it's the way we've always done something. Idioms like this one here are great examples of that. And in fact, we do this all the time. This book is based on the idea that most of our behaviors are based on things that we learned long time ago when we were children. And the idea behind this book is that self-actualization can happen when we become aware of that and decide whether those actions are appropriate in different situations. So that's the idea behind tenacity. Intuition, you're probably familiar with. It's making a judgment based on our gut feeling or a hunch. There's definitely a place for this, and particularly when you have to make a quick decision. If you're a first responder or if you're working in a medical setting, intuition definitely plays a role, particularly because it's fast. But the challenge with all of these is that they might not be accurate and they might not apply to a particular situation. Stereotypes are a great example of this problem. It's also difficult to separate what's right from what's wrong, and it's hard to correct wrong ideas. The next method is the rational method. So using our logical reasoning to find an answer. This is definitely slower because it requires that verification. And so it's less prone to error because we're taking the time to think logically through our decisions. The problem, though, is that we think we're good at logical reasoning, but it's actually pretty hard for people to do this. Let me give you an example. These 2 statements here are called premises. The last is the argument. I'd like you to decide whether this is a valid argument. So, all mothers are caring. Some caring people are supportive. Therefore, all mothers are supportive. What do you think? Do you think this last argument makes logical sense? Why don't you pause the video and see if you can figure it out? Okay, so this is the kind of thinking that you have to do for the LSATs, for example. And maybe you'll agree with me that this is actually not a valid argument. Let me show you what I mean. Let's suppose all of people, this circle here represents all the caring people. This little circle, this subset here represents mothers. This other little subset here represents supportive people. You can see that they don't overlap. This last argument is not valid. It doesn't necessarily follow that some mothers are supportive. The challenge is that when an argument seems true or seems familiar, goes along with maybe our own personal experience with our own moms, goes with our beliefs, it makes it really hard to judge whether something is valid. Here's another example. Seems like an easy question. Can you get it right? A bat and the ball cost $1.10. A bat costs $1 more than the ball. How much does the ball cost? Why don't you think about that, and I'll give you the answer at our next team's meeting. Okay, so we talked about the method of authority, intuition, tenacity, rational. Let's talk about the last one, the empirical method. This is answering questions by observing them or based on observations that we make now or observations that we've made in the past. It's based on the idea that all knowledge is acquired through our senses. So for example, judging that somebody's happy because they're smiling, or judging how tall somebody is by having a look at them relative to other objects in the room, or judging how far away something is based on cues about how big it is, or vice versa. The benefit of this is that it can vary in terms of how casual or quick we make those observations, maybe just by eyeballing, or we can also, on another end of the continuum, make more systematic, purposeful observations. For example, taking a ruler or measuring tape to measure how tall somebody is. The challenge, though, is that our observations can be misinterpreted, and illusions are great examples of this. Take a look at this picture over here. I don't know about you, but it looks to me that the monster in the back is much bigger than the monster in the front. If you pause the video, though, and measure it, you'll see that they're actually the same size. These illusions, where we've manipulated some of those distance cues to play with how we interpret size, are a great example of how our observations could be misinterpreted. And taking the time to make those purposeful, systematic observations can take a long time and could be dangerous, especially in the case of a monster is tracking you. Another downside is that sensory experiences can be swayed by our beliefs. What you see depends on what you're looking for. A great example of this is the monkey business illusion. Search it up after this video. There'll be a question about it on your quiz. So the scientific method is a different approach to acquiring knowledge. It'll be one that we talk about throughout this course. It combines several different ways of acquiring information. It combines those other ways we just talked about before. It's a process of trying to decide whether something is accurate or not. It's less about trying to decide what is fact and more about the process of acquiring knowledge and finding truth. One of the key features of the scientific method that differentiates it from other ways of knowing information about the world is that it involves formulating a specific question and systematically finding answers. So we generate a hypothesis, a prediction about what we think is going on in the world, and systematically observe it to provide data that will either support or refute our hypothesis. We'll be talking a lot more about hypotheses in a video next week. So here are some of the key features of the scientific method. It's empirical, it's public, and it's objective. What do they mean? Why is this important? Well, let's start with empirical. Just like what we talked about before in the empirical method, answers are obtained by making systematic, structured observations. How does it differ from the empirical method? Well, again, if you think of this continuum between very casual observations to very, very systematic, planned, structured observations, science falls on that far end of the continuum, where those systematic observations are made under very tightly controlled, specific conditions. This allows us to find data and find results that that we know what's going on. It'll provide support for a particular hypothesis, or that data will clearly refute that hypothesis. So again, that clear feature of science is that it involves this hypothesis that's testable and refutable. Another key feature of science that differentiates it from those other methods is that the goal is to provide objective results that are not skewed by biases. This is difficult. We are humans doing this research, and we bring our own ideas and views into the process. Next week, we'll talk a little bit about some of these biases that can happen in research and how important it is for researchers to be aware of it and try to avoid it. The point, though, is that the goal is that the process is objective. So the goal is for researchers to try to find an outcome that is as pure as possible, not skewed by those biases. And one way that we can go about doing that is because science is public. observations are made available for everyone to see by reading the methods section so that they can replicate it and see if they find similar results, and also so that it can be evaluated by others, so others can decide whether it makes logical sense what was done in a study, and whether those conclusions follow logically from what was done. So all the studies that you will read in peer-reviewed articles have been peer-reviewed. That means 4 to 5 other scientists, experts in the field, have read over the work and have provided feedback, criticism, maybe told those researchers to redo their study again. The whole goal here is that it really holds researchers to be accountable, to be honest, and to try to provide the most objective and accurate results possible. Science also involves that rational method, reasoning. In particular, it involves deductive and inductive reasoning. Let's break them down and talk about them now. Quantitative research actually relies most heavily on deductive reasoning. In this, you can think of deductive as decreasing, starting broad and going narrow. You start with a theory, you narrow it down to a specific testable hypothesis, you collect data, and the data will give you results that will either support your hypothesis or refute your hypothesis. They'll either confirm or disconfirm your theory. So again, you can think of this as starting broad and going narrow, and then collecting that data to see if that broad thing really made sense. It can also involve inductive reasoning. This is when maybe a more exploratory project, when you don't have a clear hypothesis of what's going on and you want to instead start narrow and go broad. What do I mean by that? So we'd start with specific observations, we'd detect patterns, regularities, formulate a tentative hypothesis, test that hypothesis, and then derive a general conclusion or a theory. This is inductive. Qualitative research tends to follow this process. Most of quantitative research, however, follows the deductive reasoning pattern. So here's the steps in this quantitative scientific method. You'll see that deductive reasoning coming in here. So all science starts with people just like you, casually observing the world around them, noticing things, wondering about people and why they do the things they do. Some of these observations may be based on intuition or tenacity, but what makes science different is that there is a process that's involved to see if those feelings or those hunches are actually accurate. The next step is forming a tentative explanation of those patterns that you see in the world around you, and then using the hypothesis to generate a specific, testable, refutable prediction. This involves the rational method, that deductive reasoning we talked about. The next step is evaluating those predictions by making systematic, planned observations in very narrow conditions. You can think of this as very systematic empiricism. And then using the observations to decide whether they support or refute your hypothesis, and whether maybe your hypothesis needs to be refined and you start the process again. Science is this continual iterative process. Research builds on what's been done before and others can build on. They don't call it research for nothing, as in research. So let's talk about science versus pseudoscience. How can we tell the difference between them? Well, like we said before, science is gathering evidence from careful, systematic, objective observations. Pseudoscience is a system of ideas that's presented as science, but lacks some of the key components that are essential to scientific research. Let me give you an example. Here's my horoscope. I don't know about you, but I like reading my horoscope, but I think we can all agree that it's not science. In particular, a lot of times in a horoscope, anybody can find a commonality in what they read. There's no way to test systematically some of the statements that are made here, and it's impossible to find data that would go against some of the claims that are made here. So that feature of having a testable, refutable hypothesis, being able to find evidence that goes against your ideas, being open to that, is one of the key features of science. So how do we know it's science? Well, it's empirical. Like we said, observations are used to support or refute a hypothesis. It's objective. Unbiased evidence is evaluated. That's the goal anyway. All available data is examined rather than focusing just on a few cases that confirm somebody's theory or hypothesis. We have to also look for data that can disconfirm our theories and our ideas. And again, one way that we do this is by making it public. It's grounded in previous work, and unlike pseudoscience, that is an idea that lasts for many years, science is always changing to accommodate new data. This is why we say science doesn't aim to prove anything. Science aims to provide evidence that supports or refutes your hypothesis. So let's take another example, aromatherapy. Let's look at some of the statements that are made in this ad here, right down here. Ensure a peaceful sleep with lush lavender aromatherapy pillow. Featuring blissful soft memory foam, this aromatherapy pillow will cradle you with a stress-relieving comfort day or night. Infused with lavender essential oils, you'll drift into peaceful dreams of walking in the countryside. Well, it doesn't sound very scientific to me, but how could we make it scientific? Can you generate a hypothesis out of this? How would you test some of the claims that are made here? Why don't you think about this at home, and we'll talk about it more at our next Teams meeting. So I thought that I would end this video by talking about some of the dangers of pseudoscience. This is a great example. I don't know if any of you have ever heard of this, but this is a thing. You can actually buy tinted glasses, different colored glasses that are marketed as a way of helping children that struggle with reading. Go ahead, search it up, see if you can find some. The real challenge and scary thing here is that there are parents out there who are spending money on these colorful glasses, really hoping that it will help their children when it most likely won't. There's been many years of research that have shown that one of the key challenges for kids that struggle to learn to read is not in how they see things, not how they see letters. It's not about flipping letters around. One of the major challenges is associating the sounds with speech with the letters and how they look on the page. So it's that linking. So hearing that the word cat is made up of, for example, cat is made up of 3 sounds, at, and being able to associate each of those sounds with the letters C-A-T. And we know from research that instruction that makes that alphabetic principle explicit, that linking the sounds and letters together, is really what struggling readers need. This, I think, highlights some of the dangers of pseudoscience when something is marketed that seems to be super effective, sensational news that this is going to help your children by just wearing these glasses is really scary, because parents are maybe spending money on something when they could be spending their money on more effective tutoring. So all of this is to say that hopefully for you, by the end of the course, you'll have a really clear idea of what quantitative research is, what science is, how we do science, how it differentiates from pseudoscience, and how you can be an informed reader and consumer of science to know whether to trust claims and whether they're accurate or not. So let's summarize everything we've said here. There's multiple ways of knowing and acquiring information. We talked about 6 of them. All of them have their pros and cons. The scientific method is one of them. It combines those other methods to try to achieve a more valid way of answering questions. Science is about a process of observing, asking questions, forming a tentative hypothesis, making systematic, planned, objective observations, and then using the data from those observations to decide whether to support or refute the hypothesis, or maybe to refine that hypothesis, and then sharing your findings with the world so that others can build upon what you discovered. The goal of this course is for you to learn about one of these ways that we can do science. Thanks very much for listening. We'll see you next time.